Hi guys, this is Drew here again for the next installment of our GTHO Phase 3 351 Cleveland build. Now at this stage we're up to putting the heads on, including all the valve train, the lifters, the push rods, the rocker arms, screw studs and guide plates. Now at this stage I'll just show you what I'm doing. I'm just doing a piston to valve clearance test. And although it's not a large mechanical cam, I believe that even though the lift isn't huge and the duration isn't severely long, I still believe we need to give it a piston to valve clearance test, mainly because we've machined the block so much that the pistons have come up significantly in the bore, and that will definitely affect the timing event positions of the valve in relation to the piston. So I'm going to do that test. I'll just show you. I'll flip the camera around and we'll have a look at what we're doing here now. Here we have the 4V head sitting atop the short motor, and I've assembled up the partially set up the valve train. Here I have just very light springs to replace the standard springs, because I want to be able to move the valve up and down to see how much clearance I have between the piston and the valve at any particular lift of each valve. Now what I have here is, you'll notice that I have aftermarket guide plates. I do not have the genuine factory forward OE guide plates. These are an aftermarket stamped steel guide plates with a raised guide section. Now let's just quickly go over here. I have over here on the bench, I have the factory genuine Phase 3 guide plate, and you can see the part number. Let's just have a look at that part number. That's C9ZE6A564-C. So that is also a Boss 302 guide plate, which was the same guide plate that was found on the Phase 2 and the Phase 3 engines. And right beside it here is a factory standard push rod. It's actually, you'll notice it's a little bit bent, but we're not using those. We're actually using a set of aftermarket replacement push rods, and they're the same design. They're a 3-piece design, and these just happen to be just black anodized hardened steel. Now the Phase 3 push rod was a hardened push rod, which meant that it could run through the guide plate, and the surface here on the push rod would not be affected by rubbing on the steel guide plate. So the outer surface of the push rod was hardened, and that meant that it could rub between and the guide plate itself was also hardened steel. I estimate that maybe it was taken to a Rockwell of about maybe 50 or 60, and so the guide plates are hardened steel as well. Now the rocker arms that the Phase 3 had were different to the regular OE type rocker arms. Here I have just a standard factory 351 Cleveland rocker arm. It had a fulcrum that had a positive position type arrangement. They're called a sled fulcrum, and the fulcrums were the same. They were all sled fulcrums across the range, standard and performance, but these particular ones were called a pedestal fulcrum, and so the bolt went through the fulcrum and into the cylinder head and bolted down firm, and that meant that the rocker couldn't move sideways, couldn't wobble around. It was just stationary. And so that was Ford's answer to keep the rocker arm stationary, and had its own little fulcrum that was bolted to the head. And so that particular setup is probably okay for some mild cam applications. You can see that the rocker arm has a dip right here, which you would tend to think that the rocker arm might lose some of its rigidity and strength, and I would agree with that. And so that's the standard type rocker arm, and and so really not preferable for performance applications. Now, Ford on the Phase 3 used a Boss 302 rocker arm. You can immediately notice the difference in the rocker arm. It has a straight, flatter portion here compared to the standard rocker arm. These rocker arms are also found on the early 351 Clevelands. So Ford just used a regular stamped steel rocker arm. I don't believe that the rocker arms in the Phase 3 or the Boss 302 or the Boss 351 for that matter were any different rocker arms than just the standard ones that Ford had. They thought that they were okay to use in the milder to high performance applications. Now, the difference between the standard and the Phase 3 fulcrum was that this fulcrum here is made of sintered iron. It's got a 7/16 hole, and it sits in the rocker arm, and it slides around like a sled, just like a factory standard one. It does not have the pedestal protruding out the bottom, and so it sits on the stud. We'll just place that there. It sits on the stud, and it's free to rock up and down on the stud. So, and a locking nut goes on top here. Now, the Phase 3s, to my knowledge, had a regular type locking nut, and these are some that I just found. I don't have any factory ones. The factory ones looked very similar to this. This is a tri-lobe nut. This one here has a like a tapered top on it, and so that's how it locks. And this is an aftermarket locking nut here. It has two thin plates of what look to be spring steel, which bite down hard on the thread. Now, some suggest that Ford used a half nut on top of a regular 7/16 UNF nut. I don't know or don't believe that that's what Ford did. That would have taken them a very long time to adjust each engine that was assembled, and it's too finicky, and it's difficult to get two spanners in there to be able to adjust. And so Ford would have used most probably a tri-lobe nut such as this one here on the left, and they just would have used that as a way to lock down the nut, and hopefully it stayed there. So we're going to be using a posi lock, and for those of you who don't know what a posi lock is, then it's a locking nut that has an Allen screw down. It's a longer nut, has an Allen screw down through the hole, and it locks down on top of the rocker arm. So we're going to be using that as a way to easily adjust and manage the locking down of the rocker arms. Now, one last thing that I want to talk to you about is the option that Ford would have had in their muscle parts collection, which was this. This was the Boss 302 Trans Am rocker arm and fulcrum assembly. Now, if you have a look at this particular fulcrum, it has roller bearings either side of a trunnion. Now, this particular one is just a copy of the Boss 302 Trans Am rocker arm and fulcrum, and this rocker arm is just a second-hand factory Ford rocker arm that I just had it just cleaned and CAD plated in with some other stuff. So this rocker arm sits as per normal. It uses a posi lock to clamp it down, and so that was Ford's alternative to a racing setup. Now, that fulcrum here can theoretically take more load and creates less friction. However, I don't believe that they were overly successful Ford attempted to sort of design their own roller rocker using existing parts that I had, and to my knowledge there was a lot of failures because the original bearings on either side here were needle rollers instead, and these are ball rollers, but needle rollers were quite small, lots of load put on one little particular area of the needle roller bearing, and they failed apparently. And so Ford in their muscle parts program also offered an aftermarket option, and usually it was like a Crane or an Iskandarian full roller rocker that was available in the aftermarket. And so Ford realized that their alternative was okay, but they seemed to have failures. It probably worked okay for a little while until the little needle rollers gave up the ghost, and and probably caused the demise of many an engine, with little shards of needle rollers floating through the engine, creating carnage and all sorts of problems. So that is our valve train that's the phase 3 valve train, or sorry, this is the phase 3 valve train. This is just a side option that Ford may have had. Some racers in Australia may have used this option. I don't know. It's possible. But certainly this option was simple, and it was effective, and it didn't seem to give any problems to the phase 3 engines on the street, and certainly those that raced with it didn't really have any problems and issues, although they didn't have massive spring pressures or spring loads like they did in the Boss 302 Trans Am engines, which had very high lift cams and high spring pressures. And so it's a wonder these Trans Am type trunnions gave up the ghost after a while. So anyway, we're nearing completion of the short and long motor with the heads on. So the next episode we'll continue on with some of the final additions and touches to our phase 3 motor. So we'll see you next episode.